Hi everybody, welcome today to our webinar, which is all about artificial intelligence and machine learning. And we've got a very special guest, which is Eric Lightfoot. He is a VP at the global company DataRobot. We're very excited to have him here today. He's going to be having a discussion with our very own Nick Ellis, digital transformation consultant, and also customer experience manager. And we're going to be talking about the data that you have already. So everyone collects data. There's loads of it. You're probably collecting data in your business, but perhaps you don't do much with it, or you want to do more with it. And that's what we're going to be talking about today, all the kind of magical technology that's out there now that you can use to make really great and informed decisions and predictions for your business. So without further ado, I'm going to hand over to Nick and Eric. Thanks for joining us today, guys.
Thanks for having me.
Yeah, thank you, the amazing Tess. We haven't got split screen set up on here, so you have to sort of alternate between us. But yeah, so welcome to Eric. I think you should put Eric on the screen, producers, because he's more interesting than me. So there you go. Welcome, Eric. So obviously, the point of this conversation is to think about, as Tess was saying there, about how we use our data, how we develop services and improve productivity and forecasting and all that sort of thing. And if you hear a strange noise in the background, my dog has just chosen right now to start playing with a squeaky toy, so that's excellent. Yeah, so our business, Select Technology, we are focused in the southeast of England, and we're providing IT services to businesses large and small. And one of the areas that I thought might be interesting to discuss here is around agriculture. There's a lot of that in this part of the world. There's a lot of that in most parts of the world, to be fair. And in this part of the world, it's principally fruit. There's not a lot of wheat and stuff, arable type stuff, but there's a lot of fruit growing, particularly in West Kent. And so I want to sort of talk about how data, well, firstly, what you mean by AI and ML. AI and ML, artificial intelligence and machine learning, phrases that we hear a lot of, but what do they actually mean? And then how do we apply what feel a little bit ethereal, matrixy, what is this really kind of concepts to real world practical applications that increase value in businesses? Discuss.
So thanks, Nick, for that, and thank you for such an easy, simple question to begin with. Not complicated at all. No, so let me just give a little bit of background on DataRobot and who we are. So DataRobot is a global technology company, and our mission is to bring AI and machine learning everywhere. We have a platform that allows you to, and we'll get into what this means, allows you to bring in all different types of data sources, as crude and blunt as Excel spreadsheets, and as advanced at this stage as geospatial pictures, right? And our platform will take in those data sources, help you create models that allow you to do something with them that, and this is where I'm going to pivot, allows you to make predictions in the future. So my background is economics, funnily enough. And I remember spending months and months and months and months and years looking at data sets and trying to understand what happened in the past and what the reasons for what happened in the past, what they were. That was a very inartful way of saying going into data and looking for what happened and why. And what took me by, it wasn't surprise so much as excitement. What took me by excitement when I learned about what was happening with DataRobot is that we were using very similar data sets as the ones that I used to use. A lot more data now than there was when I was doing it. But then using it to make predictions of what was going to happen in the future. And that's what, there are some people who say artificial intelligence, there's some people who say augmented intelligence, and I'll explain the difference in a second. But that's what we're talking about when we're talking about AI and machine learning, ML. It's taking the data that you as an organization or you as a country or you as a person are collecting and trying to predict what is going to happen next. Now, these are predictions. These are not decisions. And this is where it's augmented intelligence, not artificial intelligence. Your predictions are given to you, the human, right, who's working very well with the machine learning capabilities. And you're saying, okay, well, if this, then that, right? That's a very blunt, regression way of looking at things. But imagine you're taking in, rather than tens or dozens of data points, which is typically what a normal human can take in and be able to analyze. What if you could take in thousands or not, if not millions of data points and use that in real time to make predictions of what's going to happen? You as the human will then be able to go, okay, well, if all this is going to be predicted, then I can make decision A versus decision B versus decision C. And that's the back and forth that DataRobot and of course other organizations, but that's the promise of what AI and ML is bringing, is we allow the work that would take an individual days or weeks to do, we distill it down in a matter of seconds. You now have the information at your fingertips. You still have to make the decision, because at the end of the day, the machine, the software, the algorithm is just looking at this going, great, okay, cool, if this, then that, and they do it millions of times. And they say, this is what's likely going to happen. This is the 80% chance likelihood. This is the 95% chance likelihood. What do you want to do? And then as the administrator or as the data scientist or as the business partner, you then have that information to make the decision from there. And that's what we do. And that's, the nice thing about that is it's so general, is that our hardest part of our job when I'm working with customer-facing teams is trying to figure out where to start. Because you can imagine there's a lot of data out there, and everyone who's on this call will have their own data sources that they can tap into. What's going to be the most valuable from the beginning is always a tough question to answer. In the consulting world, we often say, how long is a piece of string? You have to start somewhere, and then you figure it out. So that's what DataRobot and AI and ML mean to me in a nutshell.
You're on mute, Nick.
There we go. See, it has to happen every time.
Yeah.
And again, it's the dog's fault that somebody came to the door. So yeah, I think, applying that into the agriculture world, one of the examples that I've seen quite a lot of is the potential to gather climate information and soil and temperature and all this stuff that goes into water consumption, chemical application, all the huge sources of data. And it's an area that from what I've seen, I think I know American agribusiness is we didn't really say for the benefit of those. Eric has very kindly joined us at the crack of dawn from America. It's not just an accent; he's actually there. American agribusiness is probably a bit more advanced than this than compared to European and British businesses. But there's huge amounts of data which is crunched pretty manually, Excel, and produce an Excel chart that starts to forecast how much of a given chemical we need, how much of a given fertilizer we need, how much, etc. And I think the AI, the application of AI to that, to be able to say, this is how much you need, and this is when you're going to need it. So converting that kind of, and I appreciate there's a certain irony with what's going on in supply chains, but let's think past the current moment. That what's the phrase I'm looking for? The economics phrase. It is an economics phrase as well. Of just in time. That's the phrase. But the just in time supply chain of things. Order things when you need them and have them supplied at the moment that you need them, and use them there and then. So you haven't got masses of stock and what have you. That kind of stuff on the chemicals and the machinery and what have you around that, and then also the yield forecasting, and that's an area that I talk to a lot of people about, yield forecasting. How many tons of fruit are we going to pull off of this field at the end of the year, and therefore how many people do I need to help pick it? How many people do I need to pack it, etc., etc. Now, I'm not an AI guy, but it struck me that that's a kind of a use case that is, if you'll forgive the pun, is fertile for development.
Very good. First of all, always appreciate a good pun. No, it's a very good one. So if we distill it down to kind of a bucket, what you're describing is demand forecasting. Right. So, well, in the supply chain example, we can talk about yields and everything like that, but that is essentially also looking at demand forecasting. And we've got a good example of a colossal grocer in the US called Kroger. It's one of the largest grocers in the world. And what they recognized with demand. So again, this is not soil and kind of environmental inputs. We'll talk about those in a second. I've got an idea of one that could be applicable to that type of message. But just in demand forecasting, they recognized that if they wanted to do just in time deliveries, and they wanted to make sure that they were having the absolute minimum amount of stock on their shelves at any given time, and then move it as quickly as possible, they needed to look at myriad data points and see how they interact to be able to make those decisions. So they actually invested in a data science team to say, this is what we've heard you can do, go figure it out. And that quickly turned into a team of 200 data scientists. Pretty good. That's a lot of data scientists for those counting at home. And they got absolutely overwhelmed with the amount of requests that were coming in from the business, right? Different units, different areas, all trying to get their models into production so they could do better demand forecasting. Well, the fact of the matter is that they brought in, so data scientists will build these models, but they can only move so quickly. And that's where having a platform in place really can help you scale. So they brought in DataRobot, and basically, not overnight, nothing is overnight, but once we went live with the platform with them, they were seeing a 3.5x productivity gain. And what that means in kind of real speak is that they were able to make 3.5 times more predictions, which was able to do way more just-in-time deliveries, a significant amount more just-in-time deliveries from their warehouses to their shops, and then be able to move product from there. Another example of this one is Stanley Black & Decker, which is one of the biggest producers of industrial tools, manufacturer of industrial tools in the world, and they used AI and machine learning on the DataRobot platform as well, which virtually eliminated their overproduction problems. Again, thinking supply chain, no overproduction problems. To them, this is not a small company, that meant $200 million to their bottom line, like that, just by being able to eliminate their overproduction problems.
This is the thing, actually, if I may just step in,
yeah, please.
I think sometimes we can, the hype around AI and machine learning gets, it does get a bit abstract, and I realise I started with that very, abstract question about, from and then you watch films like The Matrix and stuff, and they give you a particular view of what AI is, which is probably not enormously helpful. But the point is that it goes from, I think quite quickly goes from the ethereal and the abstract to pounds, dollars, euros, or whatever your currency of choice is, sitting in the bank rather than sitting on the shelf as inventory or sitting on the road in a truck,
So I couldn't agree more, Nick. I couldn't agree more. Sorry, I didn't mean to talk across you, but I was going to violently agree with you.
Excellent. But I think that is the challenge, I think, for people like you and for me, and is translating that abstract concept into, but the net result is not, data is the tool, and we often get so caught up with talking about data that we forget that it's not the product in its own right. And I think that's where, and you and I go back a long way, and that's this. But I'm always much more interested in what's the business value, what's the practical application, what's the thing that's going to happen differently as a result of this. And those are really good examples. So, just-in-time delivery. So I'm buying things when I need them, not in advance, and I'm selling them almost immediately. And I guess in grocery, I'm tuning more to the things that actually people want rather than the things I suspect they want, and so on and so forth. So sorry, that's got a bit shapeless at the end, but you get the idea.
It's a great point, and it's the hardest part of the application of technology or capability. Is one of the hardest things to translate to something new, right? And AI and ML is, it's not new because it has been around for a while, but the application and the applications, the relevance of it is relatively new. And we're seeing that pick up in a real way. Now, what I'd say is that what you're saying is, to distill it down again, it's trying to figure out what your company's or your organization or your personal so what is, right? So I can make 30 million predictions. So what? I can make 30 million predictions, which is going to mean that my models that go into production have a 10% improvement, and that ends up saving me $200,000 a day from unmet demand. Okay, that's a so what, because that $200,000 or pounds a day can be applied to those other projects I want to do. Pay increases to Nick Ellis and Eric Lightfoot, obviously, is probably where they should go. But but again, these are the choices that people up in accounting get to make. But again, it's the application. It's the so what. I tell my teams all the time, what is the so what here? I did live in the UK for about 10 years. So Nick and I met originally, and I'll never forget. I actually was working with one of the big grocers in the UK. It's narrowed down. It's one of a few. And I was working with them when the disruptors were coming in. So this is the Aldis and Lidls were coming in. And if you go back, geez Louise, 10 years ago or so, whenever it was about 10 years ago. This was the year that the big ones were having all different types of revenue warnings and earnings warnings, and things were not good. And I remember talking with someone I was very close with at this company, and he said, Eric, we're not going to do any new spends of any kind unless you can answer one question. What's the question? And he said, how do you put beans on the shelf? Right? If you can show me how you're speeding that up, or you're helping move beans faster, then we can maybe do something. And it was so brilliant, because here was a guy who had distilled the entire business, grocery business, almost said their name, the entire grocery business into a single so what statement. How do I get beans on the shelf? And honestly, that is the question. That's how we start. That's how we start measuring how long a piece of string is. What's core, right? So Nick, you were using an example earlier of what's our strawberry yield going to be this year, right? Okay, unless you can tell me how much tonnage of strawberry, I don't know. You guys tell me if I'm using the right phrase. What's the tonnage of strawberry going to be? We're not going to start the conversation. All right, we know what the tonnage of strawberries is going to be. How do we know how many people we need to work? How much trucking do we need? Ultimately, your big question is how much strawberry can we sell at any given time? That was a lot more difficult to get out there. How much strawberry, how many strawberries, but you get the principle. And that's the question you need to figure out. And so just from the geographic and environmental stuff, I was talking with a colleague of mine the other day, and DataRobot has a program that we call AI for Good. And you can Google it, you can find it, and there's some great stories there. But we worked with a big NGO called Global Water Challenge, and the mission of this NGO is to get more water to more people, clean water, I should say, to more people throughout the world. And so we ended up doing this project, and we helped. It's based in Africa, and we did most of our work in Sierra Leone, but we helped build the WPDI, which is the Water Point Data Index. And this is something that Water Challenge was building out with a few countries. We just happened to do most of our work with Sierra Leone. And it was, give us information about your pipes, give us information about, how people are accessing water. And they had, somewhere in the region of 10,000 data points in there, kind of across their section of West Africa. And we went in and we helped them get more data quicker. And so we're now looking at an index of well over 500,000 data points. Again, this is not AI or ML. This is just the data. And so we've now got 500,000 water points across 13 countries. But the incredible thing about this is that we are now increasing water supply across over 20,000 different water points and getting clean water to 2 million more people than we otherwise would have. Because we are able to, with environmental data points, now we're getting crowdsourcing updates. We've got GPS pictures coming in, because the AI is so good now that it can actually take pictures, it can take heat maps, and it can take in that information and analyze it, right? This is, again, anything a human can do by looking at a map, and if it is repeatable, right? If I look at a map and I can see, okay, this soil, Nick, to use your example, is really warm, and that is good or bad, then I can get that information in there that warm soil means good, cold soil means bad. That is, that is a matrix of data points now that it can help me make a decision. So I'm trying to link it back to the fruit example. But for the piping example, these organizations are now able to know which pipes are going to need maintenance before they break. And it's just, it's meant millions of more gallons of water to people who need it, because they're able to, make small changes to their pipes, little tweaks in maintenance, rather than cut off the water, dig up the pipes, rebuild the pipes, which is what happens when something bursts or breaks, which hopefully the storm doesn't test your pipes too much, Britain. As someone who's had to deal with that relatively recently, it's a real pain. Yeah. But honestly, it's one of these things that the application, right, to get back to the so what statement, the application is huge, right? It doesn't do anything that you as an analyst or a data scientist are incapable of doing. It basically puts puts your abilities on steroids because it can take in millions of data points rather than a few hundred or maybe a few thousand.
That's a very good summary. How do we scale? This is an odd thing to say about data. This is the opposite of what most people say about data. How do we scale it down? And what I mean by that is clearly the future, and as with all technology, you know, I mean, the internet itself started as a huge, you know, monopolized, government-funded, university to university, only available to a very small group of people. And then the World Wide Web was the same, and then smartphones were the same, and, you know, now this is the way it goes. So how do we get from it being the preserve, or maybe I'm being presumptuous by using the word preserve, but how do we get from it being the preserve of Fortune 500 companies and governments into this kind of culture and technology seeping into every business?
I mean, it's a
huge question. So if you can answer,
it's a big question. I'd say, you know, if I may, it's not the size of your data, it's how you use it.
Very good.
Right. So first of all, I liked that segue. I hope everyone else did, given the name of this one. But I'd say is this: listen, data science, right, is your ability to take data that you have, and I would argue that if you're a small or medium-sized business, or if you're one of the big ones, you have data, right? It's not a matter of whether or not you have the data at this point, or it's a question of what are you willing to invest to do with it. And obviously, larger organizations have more, you know, discrete pieces of data that they can touch upon. They also have the resources to be able to throw money at it. But I'll tell you, there are some large organizations that may have invested in dozens, if not hundreds, of data scientists who are not getting the return that they should out of AI and ML because, frankly, there's too much and they don't know where to start. This is where technologies like DataRobots and any others not worth looking at. But it's where technologies like DataRobots come in, which is how do we take whatever amount it is and help you create that so what at the end of it, create that actionable insight that allows you to put more beans on shelves, get more strawberries to market, whatever the case may be, get more water into homes and wells. It really is, you know, you're making me think of the old adage, right? The hardest step in any journey is the first one, but it really is true, right? It's where's my data? Okay, I know I've got all this data. Now what do I do with it? And that's where consultancies like Select, organizations like DataRobot, you know, we have seen these types of journeys start. We have seen these types of questions asked. And it's just a matter of engaging and trying to figure out the so what, and then building a plan to get there.
That's a perfectly resonant note to finish on, I think, at exactly past. So well done. Well, thank you very much. I will bring the conversation to a close there. I think there's a lot of very interesting stuff there for people to think about. It's a lot of interesting stuff for me to think about. And I will hand us back to the amazing Tess, as she's now to be known at all times, to close us out.
Great, no, thank you very much, Nick, and yeah, a massive thank you to you, Eric. Thanks for joining us, and as Nick said earlier, so early in the morning for you. We really appreciate it, and I think anyone that's viewing this webinar is going to really make them think about their data, what they're doing with it, and what they could possibly do in the future. It's really quite amazing. So I want to thank you and all of our viewers for watching today, and we'll see you next time for another Select stream. Thank you, Eric and Nick.
Thank you.